This is a story of men and methods, a story of the Ford Rouge plant on the banks of the River Rouge at Dearborn, Michigan. Factories, broad acres of buildings, ships, machines are only methods. But what is done here and how well it is done depends upon men. Methods and machines change. The earth and men endure. The earth yields her products from farm, mine, and forest. And man uses his ingenuity to transport them and build them into useful things. And so, here at the Rouge plant, as we shall see, there is no such thing as labor-saving machinery. It is labor-serving. And the more it succeeds in serving man, the more jobs it creates. But first, 8 tall stacks loom above a powerhouse, generating enough electric current for a great city. Turn the wheels and lift the loads, huge dynamos hum a song of power day and night. Intricate switchboards, dials measuring power generated and power consumed throughout the plant. This is the heart of the Rouge, a heart that pumps electric power into thousands of motors, into thousands of machines designed to lighten labor. For example, follow the path of one great artery and you'll come to the docks on the River Rouge where electric cranes reach down into the hold of a ship and bite into its cargo, or with each bite. Or that may become a part of finished Ford cars within 28 hours. From storage bins, coal is taken to the ovens, 220 of them, where coke is made for the blast furnaces and millions of cubic feet of gas are produced for use in the plant. Tons of water cool these flaming carloads, causing clouds of steam to puff skyward. When cooled, the coke is transported to the towering blast furnaces where iron is melted from the ore. There's one of the blast furnaces being charged with ore, with coke to burn and melt the ore, with limestone to flux the impurities in the ore. 15 tons in each charge dumped into the top of the furnace. Hours later, pure molten iron flows from the bottom of the huge structure to be directed through channels that lead to waiting ladle cars. Some of the molten iron goes to the foundry, covering more than 30 acres, where one of the most remarkable operations is the casting of the V8 engine block. A special technique has made it possible to build a mold with 46 cores and to cast the entire V8 engine block, including the clutch housing, in a single piece. This achievement has made the smooth power and flexibility of the V8 engine available to millions of people. Shaken out of the molds after they have cooled, the engine block castings are first smoothed. Rough edges left from the mold are cut away. Then to a series of specially designed milling and multiple drilling machines requiring hundreds of skilled men to run them, keep them in perfect operating order, and to check their work within split-hair dimensions. The Rouge plant is filled with the latest and most modern machines, yet it requires many more hours of work by human hands to produce each modern Ford V8 than it did to build the cars of bygone years. The Ford system of production depends upon the use of high-quality materials and upon precision manufacture through checks and measurements. Johansson gauge blocks, accurate to within 2/millionths of an inch, set the standards for measuring Ford parts and assemblies. Some of the testing machines seem even to possess a mechanical intelligence that no human mind could equal. The electric camshaft tester, for instance, automatically gauges 25 surfaces on each shaft and rejects those which fall below the exacting requirements for accuracy and quality. Another division of the foundry is given over to the casting of the short, sturdy V8 alloy steel crankshafts. An electric furnace is used in the process of making this special steel, and frequent test pourings determine when the metal is ready. And here, for example, is the laboratory which does just that. Close to the electric furnaces, it is typical of the Ford system of quality control. In addition to the main plant laboratories which are housed in newly completed and enlarged quarters, more than a dozen laboratories are maintained throughout the plant, and tests are made close beside the production line they control. Liquid steel is poured into hundreds of molds every hour. A continuous procession of them moving on and cooling until the forms can be knocked away, leaving 4 crankshafts to the mold. Now they are heat treated for additional strength. And finally machined to accurate dimensions, polished and balanced dynamically to establish the perfect balance of every Ford crankshaft in motion, just as it will operate in the engine. Meanwhile, trainloads of ladles carrying molten iron from the blast furnaces are moving into the open hearth department to be made into different types of steel. In one of these furnaces, a new charge is being prepared. Scrap steel and various alloys to be melted down and mixed with the molten iron that soon will be added to the charge. 52 kinds of steel are used in making Ford automobiles. 36 steels of exact formula for the car itself, 16 other special steels for tools to build the car. Then again, testing samples are taken. The time to tap the furnace is determined. And we move to the opposite side of the furnaces to see the white-hot metal flowing, soon to become 10-ton ingots for the rolling mills. Ingot, when it is stripped from the molds, is taken to a huge oven called a soaking pit, where it is brought to the right temperature for rolling. And now, with lunchtime approaching, caravans of lunch wagons move in to leave well-stocked trailers in convenient locations so that wholesome and nutritious food is close at hand. Every item on these wagons must meet a strict set of specifications set up by the Ford commissary, and prices are kept at a minimum. The men gather around and make their choice from a long list of good things. Some, of course, bringing their own food and, depending on the lunch carts, only for a hot dish, a hot drink, or perhaps a dessert. In such a tremendous plant as this, time must be scheduled to ensure steady production, and so that all do not start or finish work at the same time. Groups of men come on and go off duty with clock-like regularity. And so, in the morning, evening, or almost any time of day, you will find some workmen with their families in the Ford Community Thrift Gardens. Henry Ford believes that man is happiest and most prosperous, as he says, with one foot on the land and one in industry. So hundreds of acres of Ford farmland near the plant are made available to Rouge workmen, where each man, if he wishes, has a plot of ground to cultivate as his own for thrift, health, and relaxation. Back at the plant, we move into a long structure adjoining the open hearth furnaces where the deep rumble of the rolling mills is heard day and night. An ingot glowing with heat comes out of the soaking pit and starts its journey through the rolls. Back and forth it goes under the skillful guidance of operators who handle tons of white-hot metal with simple electrical controls. While this steel is being made ready for fabrication, other vital parts of the Ford automobile are taking form in the hands of thousands of other skilled men. Far across the plant again, to the motor building. Pistons are being finished and weighed. A weight variation of more than 1/7 of an ounce eliminates a piston, while perfect pistons go to each engine in matched sets of 8. And here, the Ford V8 engine reaches the assembly stage. The conveyor system bringing parts to hundreds of men stationed along the line. The Rouge plant, incidentally, has more than 132 miles of these conveyors. Another of the many production methods pioneered by Ford to lighten men's burdens and thus save time and human energy. engines are swung off the line at this point and connected to an electric motor for a running-in period in final preparation for a long life of dependable service. And here you see one of these sturdy V8s subjected to actual running tests under full load through a wide range of speeds. While these engines are undergoing tests, in another building some distance away, huge presses are stamping out parts for the steel frame, which will be carried by conveyor to the frame assembly line and welded to cross members. Meanwhile, other presses form the steel bodies. A 30-ton die shapes a smooth steel sheet into a complete top for an automobile. Tops, side, bottoms, each part of the all-steel body meets where the conveyors merge at a specially designed machine called a jig, where they are welded electrically. Not far away, another important part of the Ford V8 all-steel safety body is wheeling into the line of march toward a finished car. In the glass plant, you see a typical Ford development, a continuous process of glass manufacture producing better glass at half the cost of older methods. Streaming red hot from furnaces in a continuous ribbon, the glass is rolled into a flat sheet. Safety glass consists of two pieces placed together with a thin sheet of cellulose acetate between them. Heat and pressure bring the three layers of material into a permanent union. And now for the final operation. You see where you are and where you have been on a journey that would require many hours if you actually walked this route. The march of the many divisions is converging here at the final assembly line. And all the complicated and vastly different processes which you have seen were perfectly synchronized to produce the right number of parts at the right time, delivered at the right place, for the exact number of Ford V8s needed each day. Here is manpower, teamwork, and skill of the highest. This is a story multiplied 1,000,000 times or more in a single year. To this great plant, from farm, mine, and forest, and from more than 6,000 supplying companies, come raw materials and parts. From it to Ford branches in America and to many parts of the world go the finished cars or assemblies and the inspiration of a great leader. Here indeed is the heart of the Ford organization. But to Henry Ford, it is not important that the Rouge plant stands alone in size and in the leadership of an industry. But it is vastly important to him that it be of service in creating more and better things, more and better jobs.